Hello everyone, in this video we will go over the solutions to problems of the week number 4 or participation 4. The first question is just asking you to explain why the substitution method doesn't work in this case. It's not asking you to solve it. To solve it you actually have to use integration by parts, but that's not what the question is asking. So the reason why substitution doesn't work is the following. You have technically only two choices or three. Let's say that u is equals to 10x. So then du is equals to 10 dx. Since the du doesn't give you the x that you have here, then the substitution method won't work. Because if you substitute, you will end up with e to the u du, but you're still gonna need the x, so the x will be like u over 10 times the 5, so you will end it in the same place, so this will not work. And the second choice is that you could call u equals to e to the 5, e to the 10x, and therefore the u will be e to the 10x times 10, and you end up in the same place because you don't have the x. So therefore, this is a perfect example where substitution, which is a method from Calculus 1, doesn't work, and therefore you need a new method, and that's going to be integration by parts. So this method will work, you use integration by parts. The question is asking you not to solve it, but for that case, then u will be 5x, and dv will be equals to e to the 10x, and then you can solve this problem using the integration by parts. Okay, so then number 2, part A, this one does require integration by parts. Before you do that, notice you have to rewrite this so to make it easier. Notice that x cubed e to the x squared is the same thing as x squared times x e to the x squared. So therefore, this part is going to be the u, and this is going to be the dv. Okay? So therefore, if we use the integration by parts formula, remember for u, you take the derivative. So this will be du is equals to 2x dx, and then b, from db you're gonna get b. If db is equals to this, using substitution, actually b will be 1/2 e to the x squared. Okay, so now remember the integration by parts formulas as the following. This should be u times b minus b du. So in this case, ub, it will give you 1/2 x squared e to the x squared minus b, which is 1/2 e to the x squared, and then du is 2x dx. Notice that this cancel, so you end up with 1/2 x squared e to the x squared minus the integral for this is essentially this one. So that's going to be again 1/2 e to the x squared plus a constant. And this is good enough, but you can factor the 1/2 e to the x squared. So this will be x squared minus 1 plus c. You can factor this even more, but this is good enough. Okay, let's move to part B. With this question, you have to be a bit careful because in theory, it looks like if you pick u to be sine, du equals to cosine will work. But this is not going to work because then the du will be on the bottom. So the du has to be by itself. The rule is that the u has to be by itself, and it has to be always on the numerator. So therefore, du as cosine on the bottom, it will not work. And to make it worse, now you'll have the square root. So therefore, this substitution will not work. Now, the other choice you have then, the only other choice you have, is to call u cosine. So if u is cosine, then du will be minus sine, which means you just have to change all the sines into cosines, and you need to have a sine left. So for that, notice the sine q. So notice the sine q is the same thing as sine x times sine square x. And then using identities, sine square x is the same thing as 1 minus cosine square. Okay, where do I get that from? Remember that sine square plus cosine square is equals to 1. Hence, from here, we can rewrite this as the integral of sine x 1 minus cosine square x. Everything is divided by the root of cosine x dx. So the substitution is going to be this one. So therefore, from there, we'll have, this will be 1 minus u squared divided by the square of u du. You can break this into two integrals, 1 over radical u du minus u to the 3/2 du. And all of this needs a minus sign in front to balance this part. So therefore this becomes minus and this becomes plus for now. So now remember that 1 over radical u is the same thing as u to the minus 1/2. So the integral for that will be the minus I already have, u to the 1/2 times 2 over 1, and then plus u to the 5/2 times 2/5 plus a constant. So therefore, it will change back to x. This will be minus 2, the square root of cosine x, plus 2/5 cosine x to the 5/2 plus c. Okay, so now let's move to part C. For part C, you have secant and tangent. So here you have two choices. U is either tangent. If U is tangent, then that means that the U has to be secant squared, which means you have to have a secant squared left. But if you pick U to be secant, then the U will be secant tangent. Okay. And obviously all of these have the x. Okay. So how do you decide which one is it? Well, for that, notice that you have secant q here, so you won't be able to have a secant square by itself. I mean, you can have secant square, but then you have secant times tangent square, so you tangent q, sorry. So you will not be able to write everything in terms of tangent without having a radical, because you also have to use this identity. Remember that 1 plus tangent squared theta is equals to secant squared theta. So therefore, if you would have just one secant left here, then you cannot use this identity. So therefore, you want to use this identity, you can have one secant left and rewrite this as secant squared. So what I mean is this: secant q, you can write it as secant square times secant, and then you can use this secant and borrow one from this one, and then you can change everything to secant from there. So this is what I mean. So therefore you can rewrite this tangent qx, secant qx can be rewritten as tangent square x times secant square x. This should be q. And then you'll have left tangent x and secant x, which if you select u to be this, then this will be the u. So that's how you know that's what we're using. So this one is not going to work for this problem. Okay. So therefore, from here, this will be equals to just tangent square x secant square x times tangent x secant x dx. So if we use this substitution, this will be equals to u squared for this part, and then this will be the u for all of this. But we still need to change tangent square to secant. But notice that if 1 plus tangent square is equals to secant square, that means that tangent square is equals to just secant square minus 1. So therefore, this will be u squared minus 1, since u is equals to secant. So you distribute this will be u to the 4 minus u squared du, and this is pretty easy to integrate. So this will be u to the 5th over 5 minus u cubed over 3 plus a constant. And if you change everything to x, this will be secant to the 5th x over 5 minus secant qx over 3 plus c. Okay, now let's move to part D. This is probably the longest question that you've done so far. You'll see why in a little bit if you don't use any integral tables. So for now, just forget about the minus 3. And let's say that we are integrating just cosecant q. So first thing, notice the secant q or cosecant q is the same thing as cosecant square times cosecant x. Okay. Also, recall the derivative with respect to x of cotangent is equals to minus cosecant square. And the derivative with respect to x of cosecant is minus cosecant cotangent. Also, notice, to make life easier, because this problem is going to get pretty messy, I'm going to rewrite this as minus 3, the integral of cosecant qx dx, and I'm going to call this part I, the integral, so this is technically minus 3I. Okay. All right, so now I'm just going to focus on I of the integral. Okay, so here I is the integral of cosecant qx dx, which I say is the same thing as just now cosecant x times cosecant square x dx. Okay. So I'm going to select u to be cosecant x and dv to be cosecant square x dx. So using this, du is cosecant x, actually minus cosecant x, cotangent x, and b is going to be minus cotangent x. So therefore, using integration by parts, from here you're going to have the I is equals to, let me go here, I is going to be ub, which will give you minus cosecant x cotangent x, so that's ub, minus b, which is minus cotangent x, du, which is minus cosecant x cotangent x dx. So this gives you minus cosecant x cotangent x. Here you have minus and minus is plus, times minus is minus, so this is minus cotangent square x times cosecant x dx. Now from here, notice the another identity, the 1 plus cotangent square is equals to cosecant square. So that means that cotangent square is equals to cosecant square minus 1. So therefore, if you plug this in here, you'll end up with minus cosecant x cotangent x minus the integral of cosecant q of dx minus, and minus is going to become plus the integral of just cosecant x dx. Again, to get from here to here, cotangent square is this, so you multiply this by cosecant, you end up with cosecant q. Multiply by cosecant, you end up with cosecant here. Now here is the important thing. Notice that all of this is I, but I was defined to be exactly this. Therefore, you'll be able to combine this with this. That will be just like if you're trying to solve the equation, let's say x equals to 7 minus x. You will move this to this side, you will end up with 2x equals to 7, and you just divide by 2. There's one extra thing you have to take care of before you do that. Notice you need to find this integral. From calculus 1, this integral is equals to ln of cosecant x minus cotangent x. So this is an integral you're usually done in calculus 1. You can just use a substitution to get to it and the identities, but this is how we get from here to here. So now if you move this I to this side, you will end up with 2I equals to minus cosecant x cotangent x, and then plus ln of cosecant x minus cotangent x, and all of this will be plus c. Therefore, I is equals to minus cosecant x cotangent x over 2 plus 1/2 ln of cosecant x minus cotangent x plus c. But the answer, remember, was minus 3. I mean, the question was minus 3i. So therefore, the answer for the integral is actually 3 over 2 cosecant x cotangent x minus 3/2 ln of cosecant x minus cotangent x plus a constant. And that's it.